So in this lab, you're going to be collecting data to check for momentum conservation in different types of collisions. So you want to test as many different situations as possible. So we're just looking at one right here. I want to talk more about setting up the graphs and how you can pull this out to show that momentum is conserved. And so suppose we had the first case, the easiest case. We have two equal mass carts. One has some velocity, one is at rest. And so this is gonna roll down, collide here, and then we want to analyze the momentum before and the momentum after. And if momentum is conserved, then the total momentum before is equal to the total momentum after. What that means is that the momentum of car one, plus the momentum of car two is equal to 1 and 2 afterwards. So we get this relationship. So when you graph it in Capstone, one of the easiest things to pull, since you're going to be connected to the sensor, is going to be the velocity for each car. And so you might get a graph like this. So you can see the velocity of car one, and then right in here is the collision, and then car one's going to stop and car two is going to take off with the same velocity. But what we really want to see is this. So we want to see all of this on the same graph. And what this is showing is the momentum of one plus the momentum of two over time, including the collision. So we can see before and after. And what we should see is that it's constant. Now you're running an experiment, so it's not going to be exactly constant. You'll have a little bit of loss because of friction, but it's close enough for us to approximate. So what we're going to end up having is we're going to have 3 separate axes on the y. So you're going to have one for V1, you're going to have another one for V2, and then you're going to have another one which is going to be calculated, and that's going to be your total momentum. Notice I didn't put before and after because it's all included. That's going to track it in real time. And this one right here is a calculated column. So I'm going to show you how to do that. So we're going to have to create this column in order to graph everything. Now I can't show you because I'm at home. I don't have my sensors. I don't have a car. So I just had to make up some data. But what you're going to do is you're going to open Capstone. Let me get this to where you can see everything. Okay, so we're working in Capstone, and I just have a graph here. I added a table and a graph. You're going to need the table because that's where we have to create calculated columns. Again, everything's going to look a little different. So like when you select this, yours is not going to be user entered. You'll have it in your sensor. So you got to make sure you're selecting the right one. I had to create these columns to give me some value so that you can see what it's going to look like. So anyway, suppose this is car one. I'm not going to do both cars. It's more about the calculated column. So what you would do is you would add on, so you would graph the velocity of, say, car one over time. And then over here on the table, you don't need to put all of this stuff, but you're going to want to add a column. So when you want to add a column, it's this first one that inserts a column. And then what we're going to do is we're going to create a calculated column. So you select measurement, and under create new, you'll see calculation. And so for this, I'm just going to call it P1 for momentum 1. And you can do this different ways. You could do it all together if you like, but this is going to be its mass, so that's kilograms, times velocity. So kilogram meters per second. Let's put a little space there. Okay. And then notice up here, this is turned red because it's a calculation. So it's saying P1, momentum 1 is equal to what? And so now we need to enter our equation. Now, the equation for momentum, of course, is mass times velocity. And so the mass, I can just type it in. So 0.250, that would be my kilograms, times, oops, put an 8, times, and now I want to make it a variable. So I want to multiply it because the mass isn't changing. It's a constant. To insert a variable, which is determined by the sensor. So I want to multiply by this velocity 1. You put a bracket. So you see this little bracket, and then what that does is open up your menu. Now again, mine is under user entered, yours is going to be in your sensor. And I'm going to do times velocity 1. So you can see it adds that variable. So it's going to take all those velocities and multiply. So I hit enter, and now here's my momentum for all of these velocities. Again, you're not going to have all this, you'll just have the momentum. And then you would insert another one. Let's do it again, so create new calculation, P2, and kilogram meters per second. And then we'll enter the mass, so 0.250 times, this one is going to be velocity 2, because this is mass, the second one, momentum 2. So I'm going to multiply this by velocity 2. Hit enter, and it fills everything in. Okay, so that gives me the individual momentums, but what I really am interested in is the total momentum. So we're going to insert another one, create new calculation, total momentum. So I'll put total P, and that's still kilogram meters per second. So total P is going to be P1 plus P2. So again, you push bracket to select what variable you want. It's going to be P1 and then plus bracket P2. Enter. All right, so I can see my total momentum in this case is 0, and that makes sense. My momentum for 1 is 0.75. 2 is, what this is these things are coming towards each other. This isn't a real thing. I just made up some data. In fact, I should probably just change. Anyway, it doesn't matter. So it's this that I want to graph. I want to graph the total momentum on this graph. So I'm going to go ahead and we're going to add 3 columns. So I got the velocity for car 1, and what I'm going to do is add a new y-axis. So it's this little button right here. So add a new y-axis and see it, put it over here. So I'll select that, and I'm going to put velocity 2 on it. So now I can see both velocity 1 here and velocity 2 here. Oh, I'm sorry, it's reading it over here. So you see how that's -3? And then what we want to do is we want to scale these things together. It's one of these. I think it might be this one. No, hold on. Okay, so notice how this one over here, it's reading, it starts at -3, so that's over here. So you see how this -3 and -5, I want these axes to be the same. And so just right click on the graph somewhere, and you'll see all axes share origin, all axes scale together. Let's do that one. So all axes scale together. Now you can see my values here all line up. So it's easier to see what's going on in the graph. Okay, so that's my velocity for the 2 cars. Now I want to add a momentum. So we're going to add a new y-axis, and it puts it over here. So we'll go here, and I'm going to do the total momentum. So my total momentum is this red one. This is, you can pay attention to your legend. So the red one is my total momentum. So I can see that my total momentum in this case was 0 for the whole time. And so that's anyway, that's it. That's how you're going to set this up. You're going to have to create some calculated columns and add some axes, make sure everything scales together so it's readable. And then you'll write an interpretation of this for each of the different scenarios that you come up with.